Today, for this Unit 9 our homework, we'll be using the Carve University dataset and the Carve University dataset key. So we're going to go ahead and import those data first. So data and Carve, and then we're going to change the name to Carve just to make things easier. Make sure the heading says yes, and then we're going to hit import. Then let's also import our keys just in case if we need it. I'm going to change the name to Carve key. Then the heading is yes, import. Oh, they have one right here. So, and then we're gonna go ahead and open a new R square for our code, and we're good to go. So the first question is, why is the chi-square test of independence the appropriate way to determine if there's a connection between moon phase and diagnosis for those students visiting the clinic? So there are two types of two types of chi-square test. It has the goodness of fit test, and then it has the test of independence. For goodness of fit test, you have to have a proposed claim, a proposed proportion of the variables, such as equal numbers, such as blue has 30%, red has 40%, and black has 30%. You have to have a proposed proportion. And for test of independence, all you are checking is there a connection between two categorical variables. So the answer should be this one. Question number 2. Conduct a chi-square test and generate the expected count around the two decimal places and report the following cells. So in order to do any chi-square test thingy, we have to have a table. And because we're doing the test of independence, we have two categorical variables. So we have to create a two-way table first. So by creating a two-way table, we're gonna name it diamond. And then we're gonna do table parentheses, and then the data set name is Carl, then I believe it's like moon phase, and then I think it's diagnosis. I'll double check. Carl diagnosis, let me double check. Yes, moon phase and diagnosis. So we're gonna go ahead and run that, and as you see right here in the right upper window, you're gonna have your table over here, and then we're generating the expected count. So find the expected count. So we're trying to find the expected counts for in chi-square test of independence is very similar to conducting a chi-square test. We're gonna type in CHI the pop-up chi-square test, and then we're gonna put in our two-way table name, and since we're finding an expected count, we have to put at the end expect $expected, and that will give us the expected count for all the for each cells. So we have full and lycanthropy is 27.14, and the next we have partial and lycanthropy is 14.16. And then next one we have new and full and Wendy-Gosby. Full and Wendy-Gosby we have 18.86. And then the last one is new and Wendy-Gosby. We have 12.3. This is very easy. You pretty much just plug in the number that was generated from your RStudio. Question number 3. Run the chi-square test. What's the conclusion for this test? So, like I said before, running a chi-square test is very similar to finding the expected count. So run a chi-square test. So it's very similar. You can just copy and paste, but I'm gonna go ahead and type it out. Chi-square test, and then we're gonna put our two-way table. That's it. It's pretty much the exact same thing, but you just don't need a $sign and expect it. Like I said, you can just literally copy and paste. Then we're gonna run that. So we're trying to find a conclusion for this test for question number 3. So as we see here, the p-value is very low. It's less than our alpha level 0.05. So that's why we're gonna reject the null hypothesis. But what is the null hypothesis? For a test of independence, the null hypothesis is always when there's no association between two variables. So if we reject it, we don't accept the fact that they have no association. That means that they are somehow related. So the answer for this one should be they are related. Whether a student is a Wendigo, no, that's not. They are related. The moon phase of visit is related to whether the student was a Wendigo or a werewolf. So the answer should be this one. Question number 4. Which method should be used to investigate if there are an equal number of students visiting the clinic from okay, so this should be the chi-square test of goodness of fit, because you have a proposed value, you have an equal number, maybe it's 50-50%, 25% for each, so this should be a chi-square goodness of fit test.